Okay, perfect. So next we are gonna move on into predicting cost behavior. So we are going to look at different cost classifications that help us understand cost behavior. So we're going to be looking at variable costs we are gonna look at variable costs, fixed costs, and the mixed costs, which is a combination of both. And I'm going to give you a heads up here. Ultimately, it's going to become your responsibility anytime you see a mixed cost. It's going to be your job to break it down into its variable and fixed components. So when we see a mixed cost, almost always we have to break it down into variable plus fixed. So what is a variable cost? It's a cost that varies. That's a great statement. A variable cost is a cost that varies in total in direct proportion to changes in the level of activity. A cost that varies in total in direct proportion to changes in the level of activity. So as we make more and more widgets, and we're going to be using up more and more widget material. As we make more and more widgets, we are going to incur in more direct labor. So those would be variable costs that are going to vary in proportion to changes in the level of activity. And if we make fewer widgets, it's going to use fewer direct materials. If we make fewer widgets, we'll have less direct labor. So those are truly variable costs that are going to vary in direct proportion, okay? So now when we say that changes in the level of activity, well, how do we measure a level of activity? So let me make more to the right so I don't cover up. So this takes us to this concept of an activity base or cost driver. What is causing cost to happen? So cost driver is a measure of what causes the incurrence of a variable. So cost, it could be the number of units produced. If we're talking about widgets, it could be the number of machine hours. So how many hours are the machines running, producing whatever we make? And what about the labor hours that go into a particular product that we are making? So if we work more and more hours, we're incurring in more costs. Or in some cases, it could be something like miles driven. So there's actually quite a lot of different activity bases or cost drivers. And obviously, we will take a deeper look at that in a later chapter. There's an activity-based cost chapter devoted to activity-based. So now that these are your most common ones, most often we're going to be looking at things like machine hours and units produced, labor hours. Those will be your most common. So we'll take a look at, so when we think of our variable costs, as we produce more units, we incur more costs, so they are truly variable costs. As we work more hours and we incur more costs. So the cost drivers is causing the incurrence of the variable costs. So moving on to the fixed cost, a fixed cost is one that remains constant in total, regardless of changes in the level of activity. So if expressed on a per unit basis, the average fixed cost per unit varies inversely with changes in activity. So think about something like rent. Rent on the manufacturing facility, that it's fixed for the whole month, and we know that it's $20,000 per month. And whether we make 0 units of widgets or 100 units of widgets or 100,000 units of widgets, the rent is going to be 20,000. So it doesn't go up or down because we made more units of product or less units of product. Okay, does that make sense? Yes.
Yes.
Okay. So when it comes to fixed costs, some are really fixed and okay, and some are less fixed. So is that I know it seems kind of weird, but let me explain a little bit more on that topic. So there are different types of fixed costs, and we have committed versus discretionary. So a committed fixed cost is a long-term fixed cost that cannot be significantly reduced in the short term. So something like depreciation on your equipment or property taxes on your manufacturing plant. What can you do to change those things? You can't do anything really. It wasn't up to you in the first place, and now you're stuck with this long-term fixed cost that you don't have control over those. So if you want to get rid of those, then you have to get rid of the equipment or get rid of the manufacturing plant to get rid of the property taxes that go with it. So those would be some examples of committed fixed cost. And what about discretionary? We can have discretionary fixed costs. Maybe we've decided that it doesn't have to be manufacturing to be fixed. Let's say that we have an advertising contract and we pay $10,000 per year for this advertising contract. But we get halfway through the year and we decide that, you know what, we don't really need that anymore. And so we're going to cut back on advertising and going forward so we can make short-term managerial decisions and make changes to some of these costs. So we do have a little bit more control over some of these things. So those are discretionary fixed costs. Okay, still fixed. But when we talk about fixed cost, you are often going to hear us follow it up with within the relevant range. And I think that's going to be the final lesson because we still have, well, we almost finished, eh, guys? We just 4 more slides and the knowledge check, but I don't know if we will have time. Tell me, guys, what are you thinking? Okay, can we move on? This is taped, eh, guys? What I do wanted to share with you regarding terminology classes become very straightforward. Almost there is no interaction, and guys, yes, understand the terminology, but obviously as we will go and move on in the following chapters, obviously we will practice them with real examples and you will get a more clear picture of that. But this is just a little taste of what's coming. Okay, so when we talk about within the relevant range and what that is referring to, I know that it sounds kind of strange, but what that's referring to though is essentially this green area that you're watching in the plot in here, this green area, this one. We are looking at well, so let me take you a little bit of a step back. So we have in the y-axis in here the total cost, and in our x-axis you have the level of activity. And so the green line here, it's a curve, right? They call it the economist curvilinear cost function. I don't know if you want to write the equation for that. Well, I take a pass on that right now. But so what we see is that cost increases rapidly to start. So as we start making units of product, there's a bit of a learning curve, and there's a little of initial costs that go into it. And then they level off in this middle portion that you see in the green part, and which is the relevant range. And then we exceed the relevant range and they jump up again. So let's imagine that we are running a widget plant and we are making widgets. So if we make just a few units of widgets, those fixed costs are only spread over those few units. So they are quite expensive. But as we make more and more of them, we kind of hit this sweet spot. So here we are just making 100, 200, 1,000 widgets. But then as we go in, increasing the efficiency and all the units of product are sharing in the company's fixed cost, and then let's say that we exceeded the capacity of our facility, we can't make that many widgets given to this limited space, and now we have to get to a bigger manufacturing facility, and we need more space, more storage, and therefore our costs are going to get up again, which we exceeded that relevant range. Okay, now when it comes to accounting, we look at this curve and we're like we're not in this higher math kind of stuff, and there's a math class for that, and we don't much care for doing that. So we're going to draw this nice little red line right through there, and it's a pretty close approximation of that curvilinear cost function, and we're going to call that error in the middle the relevant range. So that's the accountants with the straight line approximation. Okay, so a straight line closely approximate to the curvilinear variable cost line within that relevant range. So anytime we talk about our fixed cost, it has to be within the relevant range. If we exceed that relevant range, then it's not valid anymore. Okay, so the relevant range of activity pertains to fixed costs as well as variable costs. For example, assume office space is available at a rental rate of $30,000 per year in increments of 1,000 square feet. So our fixed cost would increase in a step fashion at a rate of $30,000 per each additional 1,000 square feet. So if we were to graph that, if we need to rent 1,000 square feet, then it's going to be a $30,000. That is the first red line on the 30. Okay, well, this one. But if we need 1,200 square feet, guess what? That's not an option. We're gonna jump up to the to where we are renting 2,000 square feet, and that's gonna cost us $60,000, and so on. So the relevant range of activity for a fixed cost is the range of activity over which the graph of the cost is flat. So speaking of graphs, and this is what I wanted to show you, and I think this will leave it a little bit more clear. If we were to look at variable costs and fixed costs, and we talk about variable cost in total and variable cost per unit, look at the headers, cost in total and cost per unit. We need to be able to visualize what that looks like and what does that mean. So our variable costs in total, the total variable cost will increase and decrease in proportion to changes in the activity level. If we were to graph that, it would look like the plot I just draw in here, the first plot. Remember that the y-axis is the cost and the x-axis is the level of activity. Very easy. Linear function, guys. Linear algebra. So the level of activity.
And then the other
so if you sell or use one product, or you produce one product, a variable cost in total will vary accordingly to the level of activity. So it's just a linear function. Easy, right? So we got a sloping line. As we produce more units of activity, our costs on the y-axis are going up. So it's a straight upward sloping line. Okay. On a per unit basis, per unit though, our variable cost per unit are going to remain constant. So it's $5 of materials for every single unit we produce. So our graph would look like the graph that we have on the other side, on the top part of the per unit. That's the graph. $5 fixed. So again, activities on the x-axis, and our variable cost is going to remain constant. So it's flat on a per unit basis. So it's $5 per unit. It stays flat with it stays flat whatever we produce. So
Teacher, why does producing per unit does not depend on activity level?
can you repeat that? Sorry.
Yeah, that why does producing per unit does not depend on activity level?
Because at the end, the cost, remember that we are evaluating cost per unit. So if the mug, the example case, as usual, the mug, I sold it for 200 and it cost me 100. How much it will cost to produce 20 mugs? 20 mugs per 20 per 100, right?
Yeah.
2000 flat. It's per unit. It will be remain constant.
Okay.
Okay, but in total, as you have more activity, obviously more activity equals the same level of costs. So it's the linear function.
All right. Okay.
Okay.
Thank you. Yeah.
Perfect. So the fixed costs are fixed. Nothing more to say. It's the same as the per unit. So it would look like the same in the per unit. It's the one that it's in here. So it's $20,000 a month. Doesn't matter how many units we make. It's 20,000. It's flat. So the fixed costs are fixed. But if we look at fixed costs on a per unit basis, and that's the interesting part of the fixed cost. Cost per unit decreases as the activity level rises and increases as the activity level falls. So what's that one going to look like? And that's the plot that you have on the corner. Okay, a little bit different. So that one is actually a curve. So our fixed cost per unit decreases as the activity level rises and increases as the activity level falls. So again, our level of activity on the x-axis and our total cost, our fixed cost on the y-axis. So if we have to pay $10,000 a month for rent, if we make 0 units, it's still going to be 10,000. But if we make only 1 unit per month, then that 1 unit has to absorb $10,000 worth of rent. Now that seems crazy, right? So then if we make 2 units, then that they each have $5,000 of fixed rent attached to them. What if, and the list goes on, no? If we make 3, we have to divide it by 3, and if you keep going on, you will be obviously you will the behavior of the cost per unit will be decreasing in the curve. Okay, now we're finally going to move on to the mixed costs, and this might look a little scary to you. Kind of looks like we're back in our pre-algebra or algebra class here, right? Mixed costs contains both variables and fixed elements. So if we are talking about, for example, utilities, there's a fixed monthly utility charge just for the privilege of having electricity to your home, right? And then after that, you're billed for how much you used. So this flat red line, the one that it's in here, this flat line, that's your fixed cost. And then on the top, we add in the variable cost. So that's why it's mixed cost. This is the variable, well, the slope line, okay? So the variable component, that's the variable component on the top of fixed component, and it becomes our total mixed cost. So So if we were to break that down, because I know that we love algebra, we could look at this in a y equals a plus b format, and I really don't care which way you learn it, but we're going to refer it to it as y equals a plus bx. Okay, so what those letters all represent is y is our y-axis, and that's our total mixed cost, and a is the total fixed cost, which is going to be that vertical intercept on the y-axis in this point in here. And that's where the fixed cost intersects the y-axis, and that's our fixed component. So the v, it's the variable cost per unit, and we're going to multiply v by the level of activity, which is x.